Okay, this is 5.5 and 5.6 for MSTC Algebra 2. This chapter is coming to a close pretty quickly. We're going to finish it up this week and review, probably end up having a test early to middle of next week just to keep you informed. It's just going to be a chapter 5, not a double up chapter this time. So in 5.5, we are just working with quadratic equations and basically plugging in x's and finding the y's that go with them, or plugging in y's and finding the x's that go with them. For example, this is number 4 from the book. F of x equals negative 4x squared plus 4x plus 15. And we haven't seen too many that had a negative in the front, and that just means the parabola is going to open downward. It's going to be upside down compared to the ones that we have been dealing with. The first question is, what is f of negative 3? And f of negative 3, remember that f of anything means plug that thing in for x. So that's going to be negative 4 times negative 3 squared plus 4 times negative 3 plus 15. We just simply sub in 4x, whatever's in the parentheses. So that's negative 4 times 9, which is negative 36, minus 12, plus 15, which looks like a total of negative 33. Let's see, negative 36, yes, negative 33. So nothing new there, you can see. Part B asks us, what is x when f of x equals 20? In other words, they're giving us that y equals 20, and they want us to find the x value where that happens. Okay, so easy enough. We're doing this by hand. We know that f of x is 20, so we set 20 equal to the rest of the function. Now, we have a quadratic equation, and as we talked about in class the other day, the first thing you always do with a quadratic, whether you're going to factor it or use the quadratic formula, is that you have to make one side equal 0. So I'm going to subtract 20 from both sides to make that happen. Okay, and so now I'm not finding the x-intercepts because I've adjusted my original function from having a 15 on the end to a negative 5. But what I'm sort of finding now are the are the 20 intercepts. Where does this graph cross the line at y equals 20? So I will use, if I can factor it, I'll factor it. If I cannot, I'll use the quadratic formula. And I believe I'm going to be able to factor it. So that's going to be 2 sets of parentheses, and let's see, I've got negative 2x and a 2x, and I've got a negative 5 to break down at the end. How am I going to make this work? No, I'll take that back. I'm not going to be able to factor it. Let's get rid of that. I'm going to use my quadratic formula instead. And actually, I'm just going to check and see what the answers to the quadratic formula would be like by just looking at b squared minus 4ac. So b squared is 16 minus 4 times negative 4 times negative 5. So let's see, that's 16, and I've got a minus and a minus and a minus. 3 minuses total make minus 16 times 5, which is 80. So we get a total of negative 64. I think I got all that right. And if my discriminant is negative 64, then that means there are no real solutions to that equation. And in terms of the graph, that means that I am never going to cross the line when y equals 20. This parabola will never make it to a height of 20. So we'll look at a picture of it in just a minute, but because the discriminant was negative, we didn't even have to finish the quadratic formula. Just the fact that it was negative under the radical means that there are no such numbers. Part C, before we look at a graph, asks us for the x-intercepts. So in my original equation with a -4, a 4, and a 15, now I'm not going to set y equal to anything other than 0, and I'm just going to go from here. Now this is the one that's going to factor. Remember that the quadratic formula, it works every time, but the factoring will go a little bit quicker if you can figure out the factoring. So I think this one's going to break down to -2x and 2x. And 15 is going to break up into a 5 and a 3, and I just need to make it fit to get the 4 in the middle. So let me try, let's see, that would be 10 and 6. Let's do 5 here, 3 here, and
Please excuse this interruption. Teachers, please check your email for an email from Ms. Clay and send those students to the...
that's it. Sorry for the interruption. That'll factor to -2x plus 5 times 2x plus 3. We'll get into factoring in a later section, but I know you've done it at least some in the past. And to check your factoring, just FOIL it back out and make sure you get what you needed. When I do FOIL, I get -4x, which is what I wanted. I get 15 on the end, which is what I wanted. And then I get -6x and positive 10x, which makes a total of positive 4x. So my factoring worked. And now I can just set each part of these individually equal to 0. And let's see, in this case 5 equals 2x, so x equals 5 halves, or 2.5. And over here 2x is -3, so x equals -3 halves, or -1.5. So my intercepts, the x-intercepts, should be 2.5 and -1.5. And I'm going to pull up a picture on my calculator and confirm this info. I've confirmed that at -3, when x is -3, my y should be -33, and I'll check that. I also confirmed that my graph will never reach a height of 20. And down here I confirm my two x-intercepts to be 2.5 and -1.5. So here's my calculator. I've already got my equation plugged in, and I've got y equals 20 to see that height I was trying to determine. I'm going to go right to my graph, and here's the parabola, but I can't see it all. So if you go to Window and change your y max, the number we were checking was 20, so I'm just going to make it a number a little bit bigger than 20 and go back to my graph. So here's my parabola again, and here comes y equals 20. So you can right away see that it never reaches a height of 20, which confirms our answer to part B. Our value for -3, if you hit second trace, which is calc, and then choose option 1, value, and type in -3, you get the -33 that we confirmed, and that would be in the table as well if you wanted to look there. And then our x-intercepts are right here at -1.5 and right here at 2.5. And we've checked those in the calc. I don't want to take the time to do that right now. They're close enough, according to this picture, to confirm the two answers that we found right down here. My pen's not cooperating. But anyway, the calculator confirms what we've discovered. All right, so we'll get rid of that. And that's the majority of this section. There are problems that give you different values of y and only ask you to use the discriminant. And that's what we did anyway in part B. Okay, so 5.6, we're going to do that as well. And the main skill you need to learn in section 5.6 is to take 3 data points, or just 3 coordinate pairs, xy pairs, and find the equation of the parabola that goes through those pairs. So this is going to end up being just calculator work as well. We're just going to show you a few tricks. For example, -318 and 6, negative 9, and 12, negative 57. When we talked about lines, we determined that any 2 points would determine a line. There's only one line that goes through 2 points. If we go up a degree to quadratics, and we're looking for something in the form of y equals ax squared plus bx plus c, all you need is 3 points to determine a parabola. So these 3 points, there is one unique parabola that goes through those points. There's only one right answer, and that's our job to find it out. The old school way would be to plug in x and y, and I plug in the first point, and it would look like this. Then I plug in the second point, plugging in x for x and y for y. My 6 looks like a b. Plug in my third point, y is negative 57, a times 12 squared plus b times 12 plus c. And what you create is a system of 3 equations with 3 unknowns. We did this in class once or twice, where we solved them the long way by hand. And then we did it another way where we made them into matrices. So we would take this number, this negative 3 squared, which is really a 9, and this 36, and this 144. And we made a matrix called A out of those 9, negative 3. And the coefficient of C is 1, 36, 6, 1, 144, 12, 1. And then we made a matrix out of these and called it B, and that whole thing. And we did some matrix work in the calculator to solve for our 3 unknowns. So that would be, I'd say, method 2. The easiest method is going to be method 3, and so that's the one we're going to do. Back on my calculator, which I've closed. When this gets back open, what I'm going to do is take my 3 data points and enter them into the lists in stat. So go to the stat button and hit edit, and then I've got some stuff in lists 3 and 4, which doesn't matter. But put your x's in list 1 and your y's in list 2. So my 3 x values are negative 3, 6, and 12. So just put those in list 1 and make sure that the corresponding y gets in the right place in list 2. So for me, that's 18, negative 9, and negative 57. And there's my x's and my y's. Now, follow with me. Go back to the stat button, go to the right to the calc menu, and choose Quadratic Regression, option 5. And I think that it's defaulted to list 1 and list 2, but just in case, I'm going to type L1, L2, which is second 1, comma, second 2. And what this is going to do is your calculator will find the best fit parabola through all of the points that you enter. Well, if you only enter 3, then it will find the perfect parabola because there's only one parabola that goes through those 3. If you enter a bunch of data points, it will fit the best one. But since we have 3 data points, then it'll give us the perfect one. Okay, so what we find out, and you have to just interpret that A. Your A is negative 1/3, your B is negative 2, and your C is 15. And that's just telling us that R squared equals 1. 1 means it's a perfect fit. So using our calculator, we can determine very quickly that the equation, we can forget all of this stuff, the equation of the parabola that goes through these 3 points is y equals negative 1/3 x squared minus 2x plus 15. And there you have it. So without all that background info I gave you, you can solve these problems in a minute or less, no problem. And when we get to the word problem section, these data points will stand for real-world values, and then we'll use the equation to solve problems. Okay, so quick review, section 5, just dealing with the quadratic formula for different values of y. Nothing too fancy there, nothing really new, no new info, just practice. And then in section 6, taking 3 points, finding the equation of the parabola that goes through them. and your calculator will do that in no time. All right, so 2 and 1. Test early next week. I will see you in the morning. Young out.